Hello my dear students, once again welcome back to our online education platform for the integrated classes, the VAVA classes. तो यही पार्ट रे आमे एडिशन ऑफ वेक्टर्स रो एक्सरसाइज 4.1 रो वेरी शॉर्ट आंसर क्वेश्चन एंड शॉर्ट आंसर क्वेश्चन डिस्कशन करिबा. Now if OA equal to I cap plus J cap plus K cap, AB equal to 3I cap minus 2J cap plus K cap, BC equal to I cap plus 2J cap minus 2K cap, CD equal to 2I cap plus J cap plus 3K cap, find the position vector of D. Find the position vector of D. So solution, OD, we know that OD equal to OA plus AB plus BC plus CD. So OA is I cap plus J cap plus K cap, plus AB is 3I cap minus 2J cap plus K cap, plus BC is I cap plus 2J cap minus 2K cap, plus CD is 2I cap plus J cap plus 3K cap. Now R these we get I cap plus 3, 1 plus 3, 4 plus 1, 5 plus 2, 7I cap. Adding Jth coordinate, 1 minus 2 minus 1, minus 1 plus 2, 1 plus 1, 2J cap plus 1 plus 1, 2 plus 3, sorry, 1 plus 1, 2 minus 2 cancel, so plus 3K cap. Okay. Question number 2. If the position vector of A, B, C are minus 2I cap plus J cap minus K cap, minus 4I cap plus 2J cap plus 2K cap, 6I cap minus 3J cap minus 13K cap, and AB equal to lambda AC, then what is the value of lambda? So solution, given OA equal to minus 2I cap plus J cap minus K cap, OB equal to minus 4I cap plus 2J cap plus 2K cap, OC equal to 6I cap minus 3J cap minus 13K cap. Now AB equal to lambda AC. AB equal to OB minus OA equal to lambda OC minus OA. That is minus 4I cap plus 2J cap plus 2K cap minus 2I cap plus J cap minus K cap equal to lambda 6I cap minus 3J cap minus 13K cap minus 2I cap plus J cap minus K cap. That implies minus 2I cap plus J cap plus 3K cap equal to lambda 8I cap minus 4J cap minus 12K cap. So minus 2I cap plus J cap plus 3K cap equal to minus 4 lambda equal to minus 2I cap plus J cap plus 3K cap. By comparing, we get minus 2 equal to minus 8 lambda, that is 1 equal to minus 4 lambda. So lambda equal to minus 1 by 4. So this is the value. Or you can compare any two, you always get lambda equal to minus 1 by 4. Now question number 3. Let A equal to I cap plus 2J cap plus 3K cap, B equal to 3I cap plus J cap. Find the unit vector in the direction of A plus B. So solution, given A equal to I cap plus 2J cap plus 3K cap, B equal to 3I cap plus J cap. Now A plus B equal to 4I cap plus 3J cap plus 3K cap. A cap plus A vector, A plus B mod. This is not A cap, this is A vector B vector. So A vector plus B vector is this. So A vector plus B vector modulus equal to, we know that if A equal to xi cap plus yj cap plus zk cap, then A vector modulus is x square plus y square plus z square root over. So A plus B vector modulus equal to 4 square plus 3 square plus 3 square root over. So 16 plus 9 plus 9 root over, that is root over 34. Okay. Now unit vector in the direction of A vector plus B vector is A vector plus B vector by A vector plus B vector modulus. That is 4I cap plus 3J cap plus 3K cap by 4 square plus 3 square plus 3 square root over, that is root 34. Okay. This is the option. Let A cap equal to 2I cap plus 4J cap minus 5K cap, B equal to I cap plus J cap plus K cap, C equal to J cap plus 2K cap. Find the unit vector in the opposite direction of A plus B plus C. Solution, A plus B plus C equal to 2I cap plus 4J cap minus 5K cap plus I cap plus J cap plus K cap plus J cap plus 2K cap. This equal to 3I cap plus 6J cap minus 2K cap. So A vector plus B vector plus C vector modulus if A equal to xi cap plus yj cap plus zk cap, then A vector modulus is a square plus y square plus z square root over. So this is equal to 9 plus 36 plus 4 root over, that is 7. Okay. So it is 7, yes. So unit vector in the opposite direction of A plus B plus C is minus A vector plus B vector plus C vector by A vector plus B vector plus C vector modulus. That is minus 3i cap plus 6j cap minus 2k cap, sorry, minus 3i cap I bar, so only I bar, or you can write minus 3i. Minus 3i bar plus 6j bar minus 2k bar by 7. Okay, this is bar, not cap, but cap means I cap means unit vector. In the triangle, yes, actually this is I cap, you can write I cap or I bar. The triangle formed by the vector 3i cap plus 5j cap plus 2k cap, 2i cap minus 3j cap minus 5k cap and minus 5i cap minus 2j cap plus 6k cap are equilateral. Okay, solution. Here we have made a triangle with sides 3i cap plus 5j cap plus 2k cap, okay, 2i cap minus 3j cap minus 5k cap, another side minus 5i cap minus 2j cap plus 3k cap. Now find the modulus of these three sides. 3i cap plus 5j cap plus 2k cap modulus equal to 3 square 9 plus 5 square 25 plus 2 square 4, that is root over of 38. Again 2i cap minus 3j cap minus 5k cap modulus equal to 4 plus 9 plus 25 root over, that is root 38. Minus 5i cap minus 2j cap plus 3k cap modulus, that is 25 plus 4 plus 9 root over, that is 38 root over. Okay, so given vectors form an equilateral triangle. So given vectors form an equilateral triangle. Okay, because all sides have equal length, so it is a equilateral triangle. Now question number 6. So that the points with position vector minus 2a plus 3b bar plus 5c bar minus a bar plus 2b bar plus 3c bar, here it is bar not a cap, 7a bar minus c bar are collinear, where a, b, c are three non-coplanar vectors. Solution. Let a, b, c be the given points respectively, then AB equal to OB minus OA, that is A vector, that is A bar plus 2B bar plus 3C bar minus 2A bar plus 3B bar plus 5C bar. This equal to 3A bar minus B bar minus 2C bar. SC equal to OC minus OA. So it is 7A minus C minus 2A plus 3B plus 5C, that is 9A minus 3B minus 6C. So it is 3 times 3A minus B minus 2C. So SC equal to 3 times AB. So if A equal to lambda B, then AB are collinear. So AB, SC are collinear. Clear? Okay. So ABC are collinear. Okay. Now question number 7. If ABC are non-coplanar vectors, if they are non-coplanar vectors, then test for the collinearity of the following points whose position vectors are given. Whose position vectors are given. A minus 2B plus 3C, 2A bar plus 3B bar minus 4C bar, minus 7B bar plus 10C bar. Okay. So solution. Let ABC be the given point respectively. So OA equal to A minus 2B plus 3C, OB equal to 2A plus 3B minus 4C, OC equal to minus 7B plus 10C. Now AB equal to OB minus OA. So this is A plus 5B minus 7C. SC equal to OC minus OA, which is minus A minus 5B plus 7C. Now SC equal to minus AB. So if A equal to lambda B, then AB are collinear. So SC and AB are collinear. That implies ABC point are collinear. Okay. Now question number double I. 3A minus 4B plus 3C, minus 4A plus 5B minus 6C, 4A minus 7B plus 6C. Now solution. Let ABC be the given points respectively. Then OA equal to 3A minus 4B plus 3C, OB equal to minus 4A plus 5B minus 6C, OC equal to 4A minus 7B plus 6C. So AB equal to OB minus OA, that is minus 7A plus 9B minus 9C. AB equal to OC minus OA equal to A minus 3B plus 3C. There exists no scalar M such that SC equal to MAB. ABC are not collinear. If A equal to 2I cap plus 5J cap plus K cap, B equal to 4I cap plus MJ cap plus NK cap, and AB are collinear, find MN. Solution. If B are collinear, that implies B equal to TA for some scalar T. 4I plus MJ plus NK equal to 2T whole into 2I plus 5J plus K. Equating the corresponding components. 4 equal to 2T, M equal to 5T, N equal to T. So T equal to 2, M equal to 10, N equal to 2. Now if the vectors minus 3I cap plus 4J cap plus lambda K cap and mu I cap plus 8J cap plus 6K cap are collinear vectors, then find lambda and mu. Solution. Given minus 3I cap plus 4J cap plus lambda K cap, mu I cap plus 8J cap plus 6K cap are collinear vectors. If AB are collinear, then A equal to MB, where M is a scalar. That implies mu I cap plus 8J cap plus 6K cap equal to M whole into minus 3I cap plus 4J cap plus lambda K cap for some scalar M. So mu equal to minus 3M, 8 equal to 4M, 6 equal to M lambda. So M equal to 2, mu equal to minus 6, lambda equal to 3 by solving this. Okay. Question number 10. If A, B are non-collinear vectors with alpha equal to x plus 4y A cap or A vector plus 2x plus y plus 1 B bar, beta bar equal to y minus 2x plus 2 A bar, 2x minus 3y minus 1 B bar, then find xy such that 3 alpha equal to 2 beta. Now solution. Given 3 alpha equal to 2 beta, 3 alpha bar equal to 2 beta bar, 3 alpha vector equal to 2 beta vector. So 3 into x plus 4y A vector plus 2x plus y plus 1 B vector equal to 2 into y minus 2x plus 2 A vector plus 2x minus 3y minus 1 B vector. So 3 into x plus 4y minus 2 into y minus 2x plus 2 A bar plus 3 into 2x plus y plus 1 minus 2 into 2x minus 3y minus 1 B bar equal to 0 bar. So 7x plus 10y minus 4 A bar plus 2x plus 9y plus 5 B bar equal to 0 bar. So 7x plus 10y minus 4 equal to 0, this is equation 1. So 2x plus 9y plus 5 equal to 0, this is equation 2. Now multiply 1 with 9 and 2 with 10 and simplify. You see 43x minus 86 equal to 0. So 43x equal to 86. So x equal to 2. Substitute x equal to 2 in 2. So 4 plus 9y plus 5 equal to 0. So 9y plus 9 equal to 0. So 9y equal to minus 9, y equal to minus 1. So x equal to 2, y equal to minus 1. If A, B, C are non-coplanar vector, then show that the 4 points 6a plus 2b minus c, 2a minus b plus 3c, minus a plus 2b minus 4c, minus 12a minus b minus 3c are coplanar. Let ABCD be the given point respectively. OA equal to 6a plus 2b minus c, OB equal to 2a minus b plus 3c, OC equal to a plus 2b minus 4c, OD equal to minus 12 minus b minus 3c, AB equal to OB minus OA minus 4a minus 3b plus 4c, SC equal to OC minus OA minus 7a minus 3c, AD equal to OD minus OA minus 18a minus 3b minus 2c. So minus 4 minus 3 minus only 4, minus 7 0 minus 3 minus 18 minus 3 minus 2 determinant. You see the determinant is minus 4 whole into 0 minus 9 plus 3 whole into 14 minus 54 plus 4 into 21 minus 0 that is 36 minus 120 plus 84, which is 0. Since the determinant is 0, so FBSC AD are coplanar, so FBCD are coplanar. Okay. Now question number 11. Let A, B, C are non-coplanar vectors. Then prove that the 4 point minus A plus 4B minus 3C, 3A plus 2B minus 5C, minus 3A plus 8B minus 5C, minus 3A plus 2B plus C are coplanar. Now solution. Let OA equal to minus A plus 4B minus 3C, OB equal to 3A plus 2B minus 5C, OC equal to minus 3A plus 8B minus 5C, and OD equal to minus 3A plus 2B plus C. Then AB equal to OB minus OA, so 4A minus 2B minus 2C, AC equal to OC minus OA, so minus 2A plus 4B minus 2C, AD equal to OD minus OA minus 2A minus 2B plus 4C. Now the coefficient of FBC in FB, SC and AD is 4 minus 2 minus 2, minus 2 4 minus 2, minus 2 minus 2 4 determinant, which is 4 into 16 minus 4 plus 2 into minus 8 minus 4 minus 2 into 4 plus 8. So 48 minus 24 minus 24 equal to 0. The vector FB, SC, AD are coplanar because their coefficient determinant is 0. So FB, SC, AD are coplanar. That implies FBCD are coplanar. Okay. So this is all about the addition of vectors second part. तो ये पार्ट रे आमे बहुत गुडे क्वेश्चन सॉल्व कले. तो नेक्स्ट पार्ट रे आमे पुणी किसी थ्योरी सहित मोर एंड मोर प्रॉब्लम डिस्कशन करिबा. So till then have a nice day. Bye bye students. Thank you all.